Welcome to the class. So in this class we'll discuss about the stability of the structure and the indeterminacy and determinacy of the structure. So last class we have explained about the equilibrium of equations and how to calculate equilibrium of equations, everything. So today we'll discuss more about the stability concept. So what is determinacy of the structure? So last class we have seen basically we have three equilibrium of equations. So what are the three equilibrium equations? Summation of all the forces, summation of all the forces about x should be equal to 0, summation of all the forces about y should be equal to 0, and moment about z axis should be equal to 0. So these three equations we discussed in the last class. So these are three basic equilibrium equation for 2D structure. So now the next question is, what is the determinacy? So before going to determinacy, I just like to explain. I mean, why do we need all these? I mean, what is the implication of equilibrium equation? I mean, what is the application of equilibrium equation? So, for example, in any real structure, so for example, you consider this is a beam. So this beam is resting. So one side is a fixed joint and it is resting on a roller support. So two roller supports are there. So what is our primary objective of this course? So our objective is to basically analyze the structure. Analyze the structure in the sense we are determining the different internal forces of the structure after application of external loads. So so now the next question is whether we can determine a structure, all the internal forces whichever will develop after the external force application, whether can we determine all the forces or not. So immediately what we have is, for example, this is a beam and some load is applied, maybe UDL or maybe a point load is applied in a beam. So our immediate analysis would be to calculate what is the reaction force. So for example, so 5 kilonewton is acting in the beam. So how much out of 5, how much will go, how much will be the reaction force for this support, how much will be this support, how much will be the reaction in the fixed support. So all these things will be our first objective to find it out. So so if we can determine all the reactions of a beam or uh, of a structure using only through the equilibrium of equation, then we call it our structure is a determinant structure. Means we have already three equations of equilibrium. Summation of all the horizontal forces equal to 0, summation of all the vertical forces equal to 0, and summation of all the moment about z axis should be equal to 0. So we have these three equilibrium equations. So using these three equations, if we can determine whatever reaction forces are what are the values of reaction force in this beam, or basically we can analyze bending moment, shear force, all these things using just only these three equilibrium equations, then we call it this beam is a determinant beam. So if you use only these three equations to calculate all the internal forces of any structure, then we'll call it the structure is a determinant structure. So what is the definition of statically determinant structure? So when all the forces in a structure can be determined strictly from these three equations, strictly from these three equations, then we refer the structure as a statically determinant structure. If you can't, if you cannot determine all the internal forces and everything through this structure, then we will call it as an indeterminate structure. So that we call it indeterminate structure. So obviously we need these three equations to calculate to all the analysis done. If we can solve using only these three equations, then we'll call it as a determinant structure. If we can't, then we call it it's indeterminate structure. So now the next question is how to identify whether structure is a determinant structure or indeterminate structure. So we have three equations. So using three equations, total how many unknowns can we calculate? So from basic mathematics, you know that. For example, if you have two unknowns, so if you have, I will just write it here. If you have two unknowns, so to find out two unknown, you need two equations at least to find it out. What is the value of two unknowns? Similarly, now here we have actually three unknowns. I mean three equations. So if you see here, so we have three equations. This one, and this one for two structures. So we know three equations. So maximum using three equations, how many unknown we can calculate? So we can calculate three unknowns. So if the number of reaction forces, unknown reaction forces. If it is 3, then we can use these 3 equations and we can find it out, all the reaction forces. So that's what the statically determinant structure. So if the unknown R is basically the unknown reaction force equal to 3, where n is actually number of parts, how many parts are there. So maybe for if this beam, it is a one part, right, entire one part. So n is basically 1 here. So uh, if the number of unknown is R, unknown is the support reaction R, if it is equal to 3, then we call it the structure as a statically determinate structure. Or if the number of unknowns are more than the 3, then we'll call it is an indeterminate structure. Obviously here I have considered n is equal to 1 because I thought I have just assumed this structure is in a single piece. So this is a single piece. So n is how many parts are there in a structure. For example, these all the beams, whatever you saw, it is a single, like a single monolithic structure. So that's why n is equal to 1. But if you have two joints, then it will be n is equal to 2. So now how to calculate all these things? So now consider this beam. So this beam is a one single beam monolithic beam. It is simply supported beam. So one side is hinge support, another side is roller support. So total how many reactions are there? So in the earlier classes already we have discussed. So hinge support basically has two reactions. One is vertically upward and another is horizontal. So each hinge support has two reactions. And what about the roller support? Roller support always has single reaction. So just to recapitulate, fixed support has three reactions: hinge, sorry, the writing part, 2, and roller is basically 1. So here it is a so this portion is basically a hinge support. So you have two unknown and this is a roller support. So one unknown. So only vertical reaction is unknown, and here vertical and horizontal. So total how many unknowns are there here and how many reactions? So total we have here is 3 reactions. So 1, 2, and here 3. So 3 unknowns. So R is equal to 3. 3 reactions. And N is what? N is how many parts? So it is a single, one part, one part. There is no joint actually in the beam. So N is equal to 1. So you have, so basically this is also 3, reaction is also 3, and that is also that known forces or known equation also we have 3. So 3 fx equal to 0, fy equal to 0, mz equal to 0. So 3 reactions and 3 equations we have. So we can calculate all the 3 reactions, whatever unknown reactions will be there. So this beam is actually a statically determinant beam because we are able to calculate all the unknown reactions using the equilibrium of equation. So now if you see this beam, so here total how many unknowns are there? So this is a fixed end. So fixed end means we have already three reactions. So one is horizontal, another is vertical, and extra is moment. So this fixed end has a 3 unknown reactions. Now this is what? So this one is roller. So roller means 1 and here also 1. So total how many unknowns? So fixed end is 3, here 1 and here 1. So total we have is 5 unknowns. That's why R is 5. And what about N? N is also, it is a single section, it's single beam. So N is equal to 1. So if you, so R is 5, N is, or the total available equations we have is 3. So this beam is a statically indeterminate beam because we have only 3 equations, whereas our unknown is 5. So we cannot calculate all the 5 unknowns using only these 3 equations. We need something extra. So only using these 3 we cannot calculate all the unknown reactions. That's why we call it, this beam is a statically indeterminate beam of order 2. Why? Out of 5 unknowns, 3 can be calculated using the equilibrium of equations, but 2 we can't. So that's what we call it is a 2-degree statically indeterminate beam, this beam. So last slide, whatever I discussed is statically determinacy or indeterminacy in a simple beam. Now we'll discuss how to calculate determinacy of frame structure, because whatever multi-story building we see all around, even where we are sitting, that buildings are also multi-story buildings. So multi-story building, so we have to calculate whether if this frame is determinant or not. So determinant means, can we able to calculate all the reactions using only equilibrium of equations? So we have three equilibrium of equation for a particular part segment. There is here what summation of all of horizontal forces is equal to 0, summation of all vertical forces is equal to 0, summation of all the moment about z axis is equal to 0. So now how to calculate determinants using B. So first part, so one simple procedure to calculate is just make a section. So for example, this is the entire beam ABCD, entire frame. So we'll make a section here at the center. We'll make it into two parts. So once you make a section, and the previous process we discussed, so when you make a section, you are exposing the internal forces. So here we have taken a cut. So this portion is a cut. So when you make a cut, so you are exposing the internal force. The internal force is what? One horizontal force, one vertical force, and the moment. Similarly for here also. So basically you are exposing the internal moments in the for the two frames. So this is first top one is this part and this one is this part. So basically you are exposing three forces here and here also three forces. So these and these are same equivalent opposite sign, but the magnitude is same. So unknown here is 3 and here also 3, 6. Plus, see this support is what? Hinge support. So hinge support has two reactions. One is vertical, another is horizontal. And this is a roller support, so only vertical you have. Now total how many unknowns you have? Total here 2, here 3, and this portion here you will get 3, here 3, and this portion also you will get 3. So total you have unknown is 1, 1, 2, 3, and here 3, 6, and here 3, 9. So total 9 unknowns you have. So that's why R equal to 9. Now how many parts? As I discussed, N is actually number of parts. So in the earlier beam, that was only single beam section was there. But here we made a cut here and we separated two parts. So basically N is here 2. So what is our equation? Our equation was if R equal to 2N. So R is equal here 9, whereas 2N. So 2 into, sorry, 3N. So 3 into 2. So 6. So basically you have 9 unknowns and 6 equations you have. 6 equilibrium equations. So 3 equation for this part, 3 equation for this part, and 3 equation for this part. So total 6 equations you have. But total number of unknowns are 9. That's why this frame is basically statically indeterminate beam of 3 degrees, because 6 equations you have and total unknown is 9. So 9 minus 6 is 3. Similarly for here also, you have to calculate. So make a section here and make a section here. So whenever you make a section, you are basically exposing the internal forces. So here you will expose 3 internal force. Here you will expose 3 internal force. Here you will expose 3 internal force. So and this is all are fixed. So fixed means 3 reactions. So total how many unknowns here? 3 here, 3 here, 3 here, 3 here, 3 here, 3 here. So 6 into 3, 18. So R is 18 here. And how many sections you have? How many part? One part, middle part, and third part. So 3 parts. So n is equal to 3. So 3 into 3, 9, and 18 unknown, 9 equation you have. So this is critically indeterminate structure of order 9. So now we'll discuss about the internal stability. So earlier whatever we discussed, it is the statical indeterminacy of the structure. So our structure also should be stable after the construction. So the stability part also we have to check. So what is stable structure? Stable structure is if a structure we call it internally stable if it maintains its shape and remains rigid when detached from the support. So for example, this is a simple structure. So when you detach it from the support, so maybe earlier this was hinge support, this is pin support. When you detach, then also this structure should be stable. Like this is a stable structure. Similarly, here also this frame, this is also a stable frame. This is a truss. This truss is also a stable truss. Now, what is the unstable structure? Unstable structure means if it cannot maintain its shape and undergoes a large deformation under the small disturbance when it is not supported externally, then we call it this is an unstable structure. So, for example, if you give a small deflection to a structure, if the structure remains, so I'll just give you an example here. For example, consider this is a valley. So one ball you kept it here, another ball you kept it here. This is a hill and a valley. So two balls are there. This is one ball, that is another ball. Top of the valley we have one ball, here is one ball. So now if you give a small force in this ball, so what will happen? This ball will go up and again our this will go down. So like that, after some time again it will come to its original position. So this ball we call is a stable ball or stable structure. But if you give this small disturbance to this ball, what will happen? This ball will simply go down. It will never come to its original position here. That's why this is an unstable structure. So now external stability. Earlier we discussed about internal stability. Internal stability means if you remove all the external support, your structure should be stable. Now, what is about external stability? So, in some cases, a structure or one of its members may have fewer reactive forces in the equation of equilibrium. That must be satisfied. For example, you have three equilibrium of equations, but if you have two unknown reactions, then we call it is externally unstable structure or partial constraint basically. Similarly, in proper constraint, if you see here, this beam and both the supports are actually inclined, and both are actually meeting at some certain point here. So in that case, this structure is not a stable structure because the constraints are improper. So these constraints are improper because if you apply little external that side force, maybe an inclined force in this member is rotating, will be rotate or something like that. If you apply an inclined force, because although it will satisfy the three equations, like so how many unknowns here? So here you have three unknowns, 1, 2, and 3, because all are actually roller support, right? So you have three unknowns. So basically it is still determining structure, but it is not stable. Because if you apply any inclined force here, then what will happen? This portion will go up, move. This portion also may come down. Okay, so this beam won't be maintaining its shape like that. It will be changing shape. So that's why actually these three forces are actually concurrent. So concurrent we discussed last class. So all these three are actually meeting at same point. So this is also meeting at same point. This is also meeting. So these three reactions are actually concurrent. That's why this structure is not a stable structure. It will collapse. Here also, as we discussed, this end is fixed. This bend is fixed. But here, this is a bar. This support is basically fixed support. Okay. So that's why if we apply even side inclined load, this bar won't buckle. It will be in that position. This is a stable structure, whereas this is completely unstable structure. So how to calculate the stability of the structure? So already we have discussed R. So R is basically the reaction. So if R equal to 3, then 3n, then it is a determinant structure. If R is greater than 3n, then we discuss. No? So if R is greater than 3n, then we call it is a indeterminate structure. If R is less than 3n, then that we call it is an unstable structure. Right.